Okay, let's do try catch and error handling. Okay, so before we do the try catch, let's show what happens if we have errors outside of error handling. First of all, let's try erase error. So what we're going to do is we're just going to run this block of code because we have a return here that's going to stop this code from running. So if I just run that, you'll see we hit this line of code and we hit the second one. So we hit that line of code and we threw our custom error message. So if you use raise error, after the error is thrown, code will continue to run. And if we use throw instead, we get our thrown error message, but see, we didn't hit number 2. We didn't hit this line of code. So if you use throw outside of a try-catch block, the code execution immediately stops. So that's what I wanted to show here. The raise error does not stop code from executing, while throw does. Okay, so we don't need this code anymore. So let's remark that out. Okay, now let's look at the code we've got here. We've got a try and then a catch here. So we've got the begin try and the end try. And so here's the beginning of the transaction and the committing of the transaction. And then we've got a trans start and a trans end, and it's going to show the exact state because we are turning the exact state on. And what we're going to do is inside the begin, the try catch, we're going to raise our own errors. That's how we're going to cause it to error out. So we'll see what happens. At the beginning of the catch block, we have a message that shows that we're at the beginning, and again shows the exact state. And then we test to see if we have an error state, and then we spit out the numbers. We use the print statement to spit out the numbers and roll back the transaction. If it's committable, we commit it, which very rare is you're ever going to transfer to the catch block and actually still have a transaction. But one thing you do always want to make sure that you check the state of the transaction before you do a rollback, because you will raise an error if you try to roll back a transaction that can't be rolled back. Okay, and then we have the end of the catch block, and then we have this code here to show us if the code continued on after the catch block. So let's just, before we add an error, let's just see what happens when we run it as is without an error. And as you can see, we hit the trans start, we hit the trans end, we show that we have a state of 1 for the exact abort state. And 1 means we have a transaction that is committable. We have a kosher transaction. And then we have a statement here that shows it was committed, and then our state went to 0. And then code skipped over the begin catch. We didn't run any of the try catch, the begin catch statements. And we did run this print statement here. So we skipped over the try catch, and then code continued to execute. And that's all exactly what we would expect to happen. Okay, so now let's see what happens if we raise an error. Okay, now we do the trans start, and then we go to catch begin. So after the raise error, we did not continue on, which is what we want. We wouldn't want code to continue to run. And we did not commit. We did not get to that. We jumped immediately to the begin catch block, and we ran this line of code, which showed us that our state is -1 for the exact state, not the error state, the exact state. Those are two different things. The catch, and of course, -1 means we have a transaction that is not committable. And because exact abort makes your transactions uncommittable if an error is raised. So the transaction is an uncommittable state, so that's our line here. So that means we got to this if, and the if saw that our exact state, see there's the exact state, is -1. And then we get to use these new functions that come along with the try catch block to look at the information about the error. And so we print that information out. And what we notice here is, there is a blank line here. And that's because the function for error procedure, that's blank because we're not actually inside a stored procedure. This is just a T-SQL script. But we can see all that stuff work just fine, even though we raised an error. We didn't use the new throw, we used the raise error. So you can see raise error works perfectly fine with the new try catch stuff. And it's really what you would want to use if you actually do want to raise an error, because the throw is really meant only to rethrow an error inside the catch block, which you don't normally need to do. Normally you want to programmatically handle errors and not actually bubble up an actual error. But some people do that. Some people want to bubble up an actual error, so they would then rethrow the error inside the catch block. And one thing that will do is it will keep code from firing after the catch block, because once you do that, code will stop. So as we can see, we got to the end of the code because we fully programmatically caught and handled the error. We did allow code to continue, and so that's something you have to design into your code. Do you want the code to continue to run after the end of the catch block? Okay, so let's see what happens if we use throw instead. So throw, we can see ran exactly the same, pretty much, except we're able to set the error number. Before, we just got a generic error number, and we're not able to set the error severity. Notice we didn't set that here. Here before, we set the error severity and it showed it. Those are two minor differences between the two, and they really don't matter that much. But if you need to set this number, then throw is your only real way to do it. And if you need to set this number, if you need to set the severity, then you have to use raise error. So you might be caught in a catch-22 there. Let's see, and again, it passed execution directly to the begin catch, and all of our code in the begin catch ran as expected, and it still was able to pass the execution after the code end here, because we didn't rethrow the error. So throw and raise error function very, very similarly outside of the block. So that's one of the things about throw, is the semicolon, which is optional in every other case in T-SQL, it is not optional before you use a throw. Throw always looks for that ending semicolon. So that's another kind of got you with throw. Make sure that you always have that. Some people will actually always put the semicolon in front of throw, just in case it gets left out. You won't get an error message. So I think that pretty much covers exact abort. Okay, now that we've looked at the try catch block and the throw command and the raise error command, let's look at how we would handle error handling in a production environment in a stored procedure. So here we have just a run-of-the-mill insert data stored procedure with a try catch block, and we have a transaction, and then we have in our catch block, if we detect that there is a transaction, because you always want to make sure that you don't roll back the transaction unless there's one to roll back. So we're going to check that before we do the rollback, and then we're going to do the error handling in a separate stored procedure. That way all of our code is encapsulated in one place, so that if we decide to change how we do error handling, or maybe flip a switch by turning part of error handling on or off, like logging, turn the logging on or off, we do it in one spot. So that stored procedure will look something like this. What this does is it gets all of the new information that we can get from the error state and puts it together, concatenates it into a string, and then it re-raises that error using raise error. Now, you might not want to re-raise the error, so you wouldn't do that. You might also want to log to a table or something else, so you would put that code here as well. But let's see how this works. Well, here I've got, I'm just going to execute this stored procedure against this table, but I'm going to use a primary key that's already there. So we should get a primary key violation when I execute this, and the stored procedure should roll back the transaction. So yes, that's what we get. And notice we get message 50,000, which means that's the custom error message. So this violation primary key some table cannot insert duplicate key. This is what we would expect. This is our error that we rethrew in our stored procedure. Okay, so that works just fine. But you might think, well, why are you using raise error? Why not just, and why do all this work? Why not just use throw? Because if we did that, if we turn that off and we put throw here, this should do pretty much the same thing. So let me recompile this stored procedure. Okay, so our stored procedure is now recompiled. And now I'm going to get that primary key violation again. And yes, we got that primary key violation. So, you see the number changed, and that's because it's at the throw now instead of the raise error. So, that works as we would expect. And you would think, okay, why not just use throw? Well, throw has some issues with it. One is it absolutely requires that the line of code before it have the semicolon. And because of that, people put the colon right in front of throw to make sure that throw has it. Because this is fine, because it's optional. You can have as many of these as you want. So this is actually fine. I could compile it; it would run just fine. But without that semicolon, you typically would get a runtime error, unless you had it right after a transaction. This is the worst case scenario for throw. If you forget that semicolon after a transaction, throw now becomes the name of the transaction. So it's trying to roll back transaction throw. So that's a real problem. So I'm going to recompile this. So I just recompiled it. So it let me compile that. And the reason it lets me compile that is because throw is not a reserved word. Microsoft didn't want to break anyone's code where somebody already had a database that was using the word throw. So they didn't make it a reserved word. They really should have. But since it's not a reserved word, this compiles. So now when I do the primary key violation, we get cannot roll back throw, no transaction or save point of that name was found. And notice we did not throw the error. We have a primary key violation here, and it didn't throw that. All we get is what is basically a runtime error that's happening at runtime. A compile error. It should have been a compile error, because throw is actually should be a reserved word, but it's not. It thinks it's a name. So that's a really bad thing. See, like if we had thrown it, you can't throw after a return, but just to show throw, if you put it here, you see it gets redlined. It's not going to let me compile. It says syntax error near throw. It's not going to let me compile that. That's typically what you get unless you have the semicolon. Semicolon, now it's now it's fine, because it absolutely, see, instead of making it a reserved word, they check to make sure that it has the semicolon. But the checking to make sure it has a semicolon falls apart if it comes after a command that's looking for a name, like transaction is. So that's why I would say don't use throw, and instead use the raise error command. And of course, encapsulate your whatever error handling logic you have in its own stored procedure, and call that from all of your stored procedures so that you can fix things in one place. Anyway, that is my advice on handling errors. If anybody has a different way of doing it, if they think it's a better way of doing it, I'm all ears. I'd love to see a better way of doing this. Any questions, comments, leave below. Thank you.